Hey, 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 apes, welcome back. And here is to another unit with Miss Hoskins. This time we're on water pollution, my favorite. Water pollution is 5 parts. First, we're going to talk about wastewater from humans and livestock, and then talk about the heavy metals and other chemicals that can pollute water. We'll have to definitely mention oil pollution, and then non-chemical water pollution, which is an interesting topic. And then we're going to wrap it all up with legislation. You guessed, water pollution laws. Oftentimes, when we think about pollution, we commonly envision like scenes of dirty water contaminated with toxic chemicals and sludge spills, and these there are scenarios that are like that, and when things like that happen, it receives a lot of public attention. But there's a less familiar type of water pollution, and we need to examine these non-chemical types of water pollution, like solid waste, sediment, heat, and even noise. So, after this non-chemical water pollution section, be able to identify the sources of solid waste pollution, explain the harmful effects of sediment, because that really affects aquatic life, and then discuss the sources and consequences of thermal pollution. Heating of the whole water system is definitely no bueno, for organisms. And then understand the causes of noise pollution and how that affects organisms that live in the water, but really everybody. Solid waste consists of discarded materials that do not pose toxic hazards to humans and other organisms. And much of that solid waste is what we call garbage and sludge, and they're produced oftentimes by sewage plants. In the U.S., solid waste is generally disposed of in landfills. But in some cases, it's dumped directly into bodies of water, and it can later wash up on coastal beaches. In 1997, scientists discovered a large area of solid waste, and it was composed mostly of discarded plastics, floating in the middle of the North Pacific. This area is now called the Great Pacific Garbage Patch. It appears to collect much of the solid waste that's dumped into waters and concentrates it in the middle of a rotating current that is about the size of Texas. Other ocean currents appear to also have the ability to concentrate garbage in one area. But given the vastness of these areas, no one is certain how much solid waste is really floating there. But current estimates, they range from like hundreds of millions of kilograms. So garbage on beaches and the ocean is not only unsightly, it's actually pretty dangerous to most marine organisms and even people that live there. Plastic rings from beverage six-packs, for instance, they can make many animals struggle to swim, or, they don't have fingers like we do. They can't pull it off of their heads. And medical waste poses another threat to people on the beach, and particularly children. There was an incident during the 1970s and 80s. The public turned its attention to garbage dumping off the coast of the U.S. over by the shore where cruise ships would come in. The outcry grew when the garbage was found, including medical waste, and it had a lot of hypodermic needles in it, which is really scary if you have to vacation on the beach and have needles floating everywhere. So as a result, this practice of dumping garbage into the ocean was ended. And that happened in the early 80s. The problem remains in a lot of developing countries, though, where there's really no political mechanism to prevent dumping, or it's economically difficult to manage proper garbage, period. Another major source of solid waste pollution is coal ash and what we call coal slag. That remains behind when the coal is burned. We've talked about this before, but this waste contains a lot of harmful chemicals like mercury, arsenic, and even lead. So the solid waste produced from burning coal is typically dumped into landfills, ponds, and even like abandoned mines, where it can just contaminate the groundwater. So the U.S. EPA considers the waste from burning coal and other fossil fuels to be called special waste. And that is pretty much exempt from any sort of federal regulation for the disposal of hazardous waste. It's a bunch of crap, isn't it? Anyway, in addition, most states have either no regulations, or even just if they do, they're weak regulations that govern this whole disposal of coal ash and coal slag. As we talked about in our discussion of the Chesapeake Bay, sediments and particles of like sand, silt, and clay carried by moving water in streams and rivers, that eventually settle out into other locations where water movement is slowed, such as where streams empty into lakes and rivers, can empty into oceans and form these deltas. And the transport of those sediments by streams and rivers and other natural processes. But sediment pollution is a result of human activity. And, that can be substantial in increasing the amount of sediment in natural waterways, as we can imagine. There are numerous human activities that lead to an increase of sedimentation. Construction of buildings, for example, like requires you to dig up the soil, and then that bare ground loses some of its soil to erosion. And we've seen before that you can plowed agriculture fields are susceptible to erosion from like rain and wind. Sediments can also enter streams and rivers when natural vegetation is removed from the edge of the water body and it's replaced by crops or domesticated animals that can continually disturb the soil when they go to drink from it. So, according to recent estimates, 30% of all sediments in our waterways come from natural sources, while 70% come from human activities. And while the effect of increasing sediment caused by human activities is moving, perhaps one of the most notable things that we need to talk about is when the waterways become brown and cloudy due to that suspension of those soil particles in the water. So, increased sediment in the water column reduces infiltration of sunlight. And, everything needs sunlight in order to produce. So it decreases the productivity of all the aquatic plants and even the algae. Some sediments, they can also clog gills. They sometimes hinder the ability of fish and other aquatic organisms to obtain oxygen. And in locations where water moves very slowly, the sediments settle out and accumulate on the bottom of the body of water, whatever it is that we're talking about. And this accumulation can clog the gills of bottom dwellers. And the things that I'm thinking about are like oysters and clams. So, since the sediments contain nutrients, the pollution may also contribute to increased nutrients coming into that ecosystem. In total, the U.S. EPA estimates that sediment pollution costs $16 billion annually in environmental damage. A third type of this non-chemical water pollution is called thermal pollution, and that occurs when human activities cause a substantial change in the temperature of water. You know, thermal pollution is more common where industries they remove water from its natural source and they use it to generate things in like the manufacturing process, and then they return this heated water back to the natural supply. We've seen before that like electric power plants, they use nearly half of all the water that's extracted, and they remove cold water from rivers, lakes, and oceans. And they, when they use the water, they return it back, and it's at a different temperature. And the temperatures can be like 10 degrees Celsius to 15 degrees Celsius warmer. A variety of other industries make use of water for cooling, like steel mills, paper mills. They basically use it to clean off them or to cool down their machines. But species in any given community, they generally adapt to a particular natural range of temperatures, and so a dramatic change in temperature can basically kill them off. And this phenomenon is called thermal shock. High temperatures can also cause organisms to increase their respiration rate, and because warmer water does not contain as much oxygen as cold water, an increase in respiration and a decrease in oxygen will cause many animals to essentially suffocate that are aquatic. Recently, steps have been taken to help reduce thermal pollution by pumping the heated water into like an outdoor holding pond where it can cool before they return it back to water bodies. In fact, the U.S. EPA regulates how much heated water can be returned into natural bodies. And compliance can become a real challenge in the summertime when there's a high demand for electricity, and that causes an increased demand for cooling water, and so they pump more of it out, and it just can be a hard thing to regulate. One common solution to that problem is then to the construction of what we call cooling towers, and that releases the excess heat from the water into the atmosphere. And a cooling tower relies on the cooling power of evaporation, essentially, to reduce temperature of water. much as we depend on our own sweat and a cool breeze to cool ourselves like on a hot day. So some industries have built closed systems in which they cool the hot water in like a cooling tower, and then they recycle that water, and then they just heat it again, which is just a different way that they are adapting to those EPA regulations. So it may strike you as odd to think that noise pollution is a type of water pollution, but indeed it is. Noise pollution has received the least amount of attention from environmental scientists, and as a result, we know really the least about it. You know, when we think of noise pollution, we oftentimes think of like traffic inside of cities and stuff, but noise pollution also occurs in water. Sounds emitted by ships and submarines, they interfere with animal communication, and that's really a major concern, especially those loud sonar things that they could negatively affect species of whales in particularly. And in addition to that, some of those ships or submarines they put off this low frequency, um, and it goes a long distance, and so it can really disrupt a long range of organisms, especially in the ocean. So any animal that has this long distance communication, is affected by it. There are several instances of beach whales, like in the Bahamas, and even in the Canary Islands and off the Gulf of California. They've been connected to military sonar, and those loud underwater air guns by energy companies that are searching for oil deposits in the ocean will also cause these whales to beach themselves. Actually, in 2003, a federal judge rejected the U.S. Navy's request to install this network of long range sonar systems across the ocean floor. They wanted to detect incoming submarines because of suspected negative impacts on endangered whales and other species of marine life. And then even in 2008, the U.S. Supreme Court ruled that the President of the United States could exempt the Navy sonar effects on ocean life. To better understand noise pollution in the ocean, the U.S. National Oceanographic and Atmospheric Administration announced that in 2012 they had completed the first step in mapping the noises across different regions of the ocean. And at that same time, an increase in awareness of noise pollution in the ocean has inspired from all of that. And some shipbuilders are now trying to design ships and equipment that have quieter propellers. So just to recap this section here of non-chemical water pollution, there were four different major types of pollutants, right? The solid waste, sediment, and the thermal and the noise. And they all have different sources like garbage, sludge, plastics, and coal ash from make solid waste, and construction sites and poor farming from sediment. Even electric power plants and industry create thermal pollution, and sound emitted by ships and submarines, they interfere with animal communication. Those can cause a lot of noise pollution. Each of those things has an effect on the wildlife and things that live there, and also have a solution to the problem. Like solid waste, we can create laws and penalties for dumping. Find those who violate those laws and ticket them, and also do like public relation campaigns. And sediment, we can use silt fences at construction sites, and even mandate that the riparian zones have some sort of like buffer region before sediment rolls into a river. When it comes to those thermal pollutions, we can monitor and regulate water temperature at power plants and manufacturing facilities. I mean, that's the thermometer, and that's easy to do. We can even require cooling towers to be discharged into like lagoons. And noise technology's gotten there to where we can require large ships to use quieter propellers. I mean, change out their engines.